it's Mrs. C. I'm going to have a picture of the pumpkin and sunflower in for the intro because I'm not looking very good, and I, as you guys know, had a big procedure at the dentist today, and I'm still not talking very well, and I'm drooling a bit, so I just don't want you guys to see me like this. But I still want you to get the lesson, so you can admire our gorgeous pumpkin and this lovely sunflower. I hope you guys had a great day today with your guest teacher. I hope we got a lot done. As you guys know, we're going to get into, that's me drooling. We're going to get into the first lesson of Module 2, and we're going to, in Lesson 1, we're going to decompose the numbers a bit, and then we're going to multiply them in more simple forms. And it's going to be wonderful, and let's get going here, guys. Kiddos, here we are getting into L1 on today, 10, 15, 18. Okay, so what we're looking at in this lesson is going beyond just memorized mindless rules. So traditionally, the way that we would go about learning 40 times 30 is we look at 4 times 3, which is 12, and then we see 1, 2 zeros. Yes, 40 times 30 is 1200, but we're not going to focus on this mindless rule. We're going to think more deeply because you guys have amazing number sense. We're going to think about what does this mindless rule actually mean. I mean, it's certainly valid and it's certainly helpful, but we want to go beyond just memorizing a rule. And like I said in the intro, what we're going to do is tear apart these numbers, decompose them a bit, and look at these numbers more deeply. So let's look here at 23 times 20. Obviously, there's been a lot of work done here for us, and we're responsible for filling in the blanks, but let's go ahead and talk through this. So we have 23 times 20. In unit form, that looks like 23 ones times 2 tens. Okay, so now for this blank, we have to think about, what is 23 times 2? If that isn't immediately obvious, please feel free to do 23 times 2 on the side. 23 times 2 is 46. So unit form here is 46 tens. What does 46 tens look like in standard form? Well, it's 46 tens, 460. Cool. Let's go ahead and look at this one. B is very similar, but we have a different place value here. So now we're looking at 230 times 20. The first line, we're going to think about unit form. 230 is 23 tens. 20 is 2 tens. So what we need to do for the blank is rewrite this in unit form. Let's look at tens times tens. What is 10 times 10? Well, 10 times 10 is 100. So I'm going to follow the pattern and I'm going to write that. In unit form. And then we have to look at 23 times 2. Well, I already did that work over here. I know 23 times 2 is 46. And this is multiple hundreds, so it's 46 hundredths. So the final answer for 230 times 20 is 46 hundredths in standard form, which is 4600 or 4,600. And this makes sense because 23 times 20 and 230 times 20 are very similar, but 230 has one more zero than 23, which means the resulting product here has one more zero than 460. So that makes some sense. Let's go ahead and skip down. I'm really sorry if it's difficult to understand me. I can't move my jaw that well, or it's very sore, so I'm talking kind of with my mouth closed. So I hope you guys are just making the best of this as I am. Tomorrow, on Tuesday, I will be all better. I'm still in the funny position where the Novocaine and the medicine is wearing off, so I'm kind of slowly getting my ability to talk well back. And I hope by tomorrow I will not be drooling, because that is very embarrassing to drool in front of your 5th graders. Okay, so let's look at E here, you guys. We have 3,310 times 300. First line, we're going to rewrite this expression in unit form. So 3,310 is 331 tenths. And then we have 300. This is actually really nice because they've done this part for us. Eureka has provided us with the product of 331 times 3. That's 993. Now we need to figure out the unit. What is 10 times 100? So 10 times 100. 10 times 100 is going to be 1,000. I'm going to try it. There we go. So we have 993 thousandths because 10 times 100 is 1,000. So for our final answer here, we are going to take 300ths and 909. No, I'm so sorry. We're going to take 993 thousandths and put that into standard form. And that is going to look like this, 993 thousandths, or 993,000. Do you guys see how we're decomposing the number? The reason why we're decomposing these numbers is so that we can look at it in smaller bits, hopefully more manageable bits. And we're relying on our understanding of unit form to rename these numbers. And then, of course, here for the final answer, we're putting our numbers back into standard form. Let's look at one more here. F and F, we are looking for the product of. Remember, the product of is just the fancy term for the answer to a multiplication problem. We have 500 times 600. So here on the first line, what we're going to do is rewrite that expression in unit form. So we have 5 hundredths, that's this one, times 6 hundredths. And in our unit form, we're multiplying our digits. We have 5 times 6 is 30. That's been done for us. But now we need to figure out what is our unit. When we're multiplying 100 times 100, what we're going to end up with is 10,000. 100 copies of 100 is going to result in 10,000. So this is going to be 30, 10, oops, sorry guys, 30 10,000. And now for our final answer, we want to put our 30 10,000s into standard form, which is going to look like a 30 our result is going to be 300,000. Let's look at a couple more examples here, guys. Kiddos, for this next section, I actually cut out the directions or the instructions, but as you kind of glance across the screen, you can see that we have a bit of a progression here in our original expressions. And you can see that we start with a very basic expression that we all have memorized, hopefully, to begin with, and then our expressions increase in complexity as our place values grow larger and larger, or as the digits, some of our digits shift to the left in the place value chart, thus increasing the powers of 10. So this part A, this is just an example to show us what we need to do in each of the sections. And so we're going to model this progression in part B. So very simply, here in the first section, we're looking at 7 times 9. We have a different expression here. We actually have 45 times 3. And we can just go ahead and, oops, first of all, don't change the problem like I just did. That will result in an incorrect answer. Let's look at 45 times 3. We have 5 times 3 is 15. Were you looking?
I'm sorry, someone died. Famous died inside.
Who?
Paul Allen, the guy who owns the Seattle Seahawks and co-founded Microsoft.
Oh, sad. Mr. Kalmer's working right beside me, and he just encountered some interesting news. That is sad. Okay, so we have 5 times 3 is 15. We bring our 10 over. 4 times 3 is 12. Plus 1 is 13. So 45 times 3 simply is 135. Now let's look at 45 times 30. What we're going to do here, you guys, is actually decompose our problem so that it looks like this. We'll look at 45, didn't leave myself very much room, times 3 times 10. So we have 45 times 3 times 10. Do you guys see how I decompose 30 into 3 times 10? Using the power of the associative and the distributive property, I can rearrange these numbers since we're dealing with multiplication. In multiplication and addition, it doesn't matter in what order that we execute these expressions because we're dealing with multiplication. So let's go ahead and use those properties, commutative and associative, and let's rewrite the expressions so that we have 45 times 3 and then that times 10. The reason why we're doing this is that we've already figured out the 45 times 3 is 135, and then using what you know about your place value understanding in Module 1, we can do 135 times 10 quite easily. Just think about 135 in the place value chart, and just think about the fact that each of those digits are going to shift over one place value to the left because we're multiplying by 10, and our resulting product is going to be 1,350. So let's do that again here, you guys, and let's continue to, I'm going to change my ink color. Let's continue to decompose these numbers. So here we're looking at 450 times, oh, my battery's getting low, of course. No! I'm just going to have to pause this for a second. Okay, guys, I am back. Sorry about that. I had to plug in my computer. Okay, so we're going to continue decomposing the numbers. Here we're looking at 450 times 30. So we're going to, I think I'm going to kind of move this down here. We're going to continue using the powers of the associative and commutative properties. And, but actually, before we do that, we're going to decompose these numbers. So let's rewrite 450 as 45 copies of 10, and let's rewrite 30 as 3 copies of 10. And then here is our chance to invoke the powers of the associative and commutative property, and we're going to kind of rearrange these numbers. The purpose of rearranging these numbers is so that we can do so that we can evaluate these expressions mentally. So we already know, because we did that in the first problem, what 45 times 3 is. So let's go ahead and rewrite our first expression as 45 times 3. So we've used that guy and that guy, and then we're left with our 2 10s, 10 times 10. It would be difficult to do this in our head in a meaningful way. That's why we're decomposing them, rewriting them, so that we can really understand that old-fashioned rule that I talked about in the very beginning of the problem. We're not just mindlessly slapping zeros at the end of the number. We are evaluating these expressions in a very thoughtful way so that we understand why that rule is actually mathematically sound. So 45 times 3, we did the work in the very beginning. We know 45 times 3 is 135. So now we're looking at 135 times, I guess I don't have to use parentheses, I'm really, okay, so now we're looking at 135 times 100. You guys know if we put 135 in a place value chart, we multiplied it by 100. You guys know that the digits would shift to the left 2 places, and our resulting product would be 13,500. Very good work here, guys. We're going to do one more. And before we do one more, I'm going to tell you our secret word. I'll actually write it here. Secret word of the day is this. And I hope you guys know why. And I also hope that I'm not doing this tomorrow in class. Hopefully I will get my wits about me tonight, and I will return your normal, semi-normal at least, 5th grade teacher tomorrow in school. So the secret word for this lesson is right here written in green. Let's look at 450 times 300 now. We're going to decompose both of these, and then we're going to rewrite them or rearrange them using the associative and communicative properties, and then figure out what our final product is. So 450, we're going to rewrite 450 as 45 copies of 10. So that's our first decomposition. And then we're going to decompose 300 as 3 copies of 100. Okay, now we're going to rearrange things so that we can do this mentally. So I'm going to rearrange these numbers, and I'm going to rewrite the first expression as 45 times 3. And we're seeing this again. Okay, of course, we figured out what 45 times 3 is at the very beginning here. And then we're going to use this and then. Then we're going to write the expression we're left with 10 times 100. So let's go ahead and evaluate these and see what we get. 45 times 3, you guys know, is 135. So we're going to be looking at 135 times the product of 10 and 100, which is 10 copies of 100 is 1,000. So let's think about 135 on the place value chart. We're going to multiply it by 1,000, which means each of these digits is going to shift to the left 3 spaces, and our resulting product for 135 times 1,000 is going to be 135,000. Cool, so we will continue to practice this tomorrow, you guys. I can't wait to see you guys, hear all about your wonderful weekends and your wonderful days. See you guys in the morning. Thanks for watching.